The following content has been provided by RWTH Aachen University.
But yeah, there are some issues with this formulation. And does anyone see where a problem might lie? So what would happen if this gets really small? You all had math in school. A logarithmic of less than 1?
Nodes would get negative?
Yes, would get negative. And, well, if you think about this, I would go into the future? No, I would go back into the past. So, well, more Star Trek than real world. So there were some improvements. And the first one was by a guy named Werford. And he basically dropped the 2 from, so he didn't double the distance, but he instead added a 1/2 up on that. And another formulation later in the 80s by Shannon was actually made then into the ISO norm that you can is actually the standard that you can use. And there is here a +1, so get rid of the problem of negativity overall, and also has 2 more factors or more values in front. So the B is the index of movement. So for rough estimates, you say, well, A is 0, B is 100 milliseconds, and you have sort of the original formulation. But when you do tests, you test a device empirically, you can improve A and B so that this formulation works better for this input system that you're using. And there are, I think, quite a few formulations for different ones. So pen input or mouse input, joysticks, they all have these different parameters associated with it. So what these optimizations did, when we look visually, with the original formulation, if you had the distance was smaller than half your width, you would have a problem there because, well, you get negative times. And what it means graphically, well, you're sort of already over your target. And then you're still not tapping it in the past. So that was a problem. Werford's formulation improved this a little bit. But then with Shannon's formulation, you won't get negative targets or negative times even if you're directly above the target already.
This content was provided by RWTH Aachen University.